So let us cover recommendation system. As we can see, recommendation system can be of multiple types. One is content based, as in what is the content of a movie. If you're talking about from movies, or what is the color of an item, what is the style. Other is collaborative filtering that we'll study in detail. Other is popularity based, like the most popular items should go ahead, right? Now, to go on collaborative filtering, there are two methods: neighborhood or content based and model based. Neighborhood and content based are of user based collaborative filtering and item based. And these three metrics are: one is clustering based, one is matrix factorization, and another is deep learning, which is based on autoencoder. So if you really study mostly about collaborative filtering, which is one of the most popular method, we make a user item matrix. Each user, and for each item, we find their ratings or their interaction on a scale of 1 to 5. And this is generally a sparse matrix because we don't have a user doesn't really interact with a lot of items, only it only interacts with subset of the items, right? So now given this matrix, this forms the base to recommend a system problem, which is we need to predict that for this user what should be given as an item, right? Or and what rating will this user give to them, because higher rating means we should recommend to them higher predicted rating. So if we see collaborative filtering, the first one is memory based model, or the what we were talking about. There are two types of way to do this. One is what we call as user based, another is item based filtering. So user based and item based. How does it work for user is, for every user, suppose I am a user, I will find similar users to me based on maybe demographics, maybe based on rating vector, that we'll just see. And all the similar users that I have, that are similar to me, we get the rating of those users for that particular item I, and maybe we can take a weighted average, whatever, to give the new rating. Whereas in item based, first we select an item, let's select airport, then we'll find a similar items that I have purchased to airport, right? So once I have those similar item, we will see the rating I have given to those similar item and see if I will like item I or not. So these are two memory based model, what we say. How to calculate similar users is simple. We can maybe just take these ratings I have given to certain movies, and we can find metrics such as Euclidean distance, right? So if we see the Euclidean distance being less, means these two uh, so I have rated user B and user C have similar preferences. So B and C are similar user. We can also use cosine distance, as we see, right? If we talk about C, we see that though D looks closer here, but actually A is closer. Why? The reason is that we will say C, but looking at the ratings, it would seem that C would align with that of A more than D, because both A and C like the second movie almost twice as much as the first movie. But so that's another way to do this. So we can measure this angle using cosine similarity as a distance, right? And similarly, we can calculate the rating as well as I said, right? Two ways: either just average rating of similar users, or do a weighted average based on the distance, the similarity of users. So if I have five users, I will give higher weight to the most closer user. That is collaborative filtering in a nutshell. Then second is model based. In this, the key idea is of matrix factorization. So this is our user matrix we factorize into user dimension and item dimension, M and N, and these two are called latent features. So one example could be, this could be a genre, can be a little feature, right? So horror genre, or let's say romance genre, right? And this shows my affinity, my interest in that genre, and this shows how much of particular item belongs to that genre, right? So and the multiplication of this will give my express my rating, right? But this is just an example. Latent dimensions, when we factorize the matrix, right, into two matrix, where when we factorize an m cross n matrix into m cross p and p cross n, where p are the latent variable, there can be anything, and we can use it to decouple. Okay, so we have this library called surprise, which we can use to basically do different kind of things, right? So one I wanna to, for different kind of recommendation systems, one algorithm is called KNN, with means for memory based models. So one factor is that a user can attribute rating higher to So everyone has different propensity. Some gives very high rating, some gives very low rating. So let's subtract the mean rating for all the users, right? That's what KNN with means do. It removes the user bias because and standardizes the rating of every user around zero. That method can be used. Also, there are factorization method available in surprise package that you can use for like SVD and other thing. Um, let's look at a few more ideas. So this is the other idea that we were talking about, number of users into number of items. These are called latent variables, as we were saying, and we use these two metrics to get values of these two metrics. We can initially randomize those and use this as a target metrics to get the results. We do see there are some missing values which there are ways to handle, but let's see how can we further see this. So this is again the same representation. So we are calling this P and we are calling this Q, right? And when we see, so there are different metrics to factorization. One is a simple method where we need to get R from Q and P, where Q user is associated with P underscore U and item with Q underscore I. So we want to get this, so error becomes the actual matrix minus P into Q, which gives us the variable, and we put a regularization because there is a lot of sparsity in this, and to avoid overfitting, we penalize the values of P and Q. That is one way to factorize. Second could be we handle for the biases of the rating bias. So we add few more parameters called B, which is the global bias, WI, which is item bias, and WU, which is user bias on particular values. And again, we can improve our loss function and train it with SGD or whatever algorithm we want to. One could be side feature. This is like incorporating purely some features of a domain knowledge around demographics and all as variables. That is also what we can do to do the recommendation system. And then there are temporal features. We can, there are different things we can add a time bias as well. So this is how we do it. We initialize it randomly, calculate the error, and then we do regularization and get those variables, right? This is again, this conveys a similar idea. One of the ways to factorize the matrix is also SVD. SVD algorithm again, it factorizes into three matrices where the one is orthogonal, other is diagonal, and other is also orthogonal matrix. The key idea between SVD in machine learning is it helps reduce when we factorize a matrix, it immensely helps compress the data and store the important features in the factorized form, important information. That's where you can use SVD in general.